Okay, now let's say I want to find cosine of x in terms of tangent of x. Just like the last couple problems that we covered when we went through the homework, we have to use Pythagorean identities to figure this out. But in the two problems you had assigned for today, you already had a Pythagorean identity with cotangent and cosecant involved together in the same one, and secant and tangent involved together in the same one. You don't have a Pythagorean identity of a cosine and a tangent in one, do you? No, you don't. So, cosine goes with sine, but if you turn tangent into sine over cosine, that's going to make it too complicated. We're not going to go there. So, what's the Pythagorean identity with tangent? Secant. Does cosine have anything to do with secant? 1 over secant is cosine, right? So, if I use a Pythagorean identity, secant squared of x equals tangent squared of x plus 1. Okay? Then, let's change secant into cosine. So secant squared is 1 over cosine squared of x. But I want cosine, not 1 over cosine. So I have to do what on both sides? Find the, starts with an R, R-E, R-E-C, a reciprocal. Yeah, take the reciprocal of both sides. So cosine squared of x equals 1 over tangent squared of x plus 1. Now I have cosine on one side, tangent on the other side. I'm doing good. What do I do to both sides right now? Take the square root. Okay. What's the square root of 1? 1. So cosine of x equals positive or negative 1 over the square root of tangent squared of x plus 1. Do we leave radicals in the denominator? No, so we just multiply top and bottom by the square root of tangent squared of x plus 1. So the cosine of x is equal to positive or negative square root of tangent squared of x plus 1 over tangent squared of x plus 1. Let's do one more of those. All right, let's write secant of x in terms of cotangent of x. Let's write secant of x in terms of cotangent of x. Do we have a Pythagorean identity with both secant and cotangent in? No. So, should I change secant to something else or cotangent to something else to match up with a Pythagorean identity? Well, what's my Pythagorean identity with secant in it? Tangent, right? So I have secant and tangent together. I can change cotangent to tangent pretty easy. What's my Pythagorean identity with cotangent in it? Cosecant. Can I change secant into cosecant easily? Is there something to change secant into cosecant? Not really. So I'm going to use the secant one and tangent one. So I'm going to say secant squared of x equals tangent square root of x plus 1. Ooh, yep, that's what I want. Now, how do I change tangent into cotangent? Yeah, it's just 1 over cotangent. Now, before we can take the square root, I could take the square root of each side, but it's going to be kind of messy here. So I need just one function on the right-hand side. How do I change it to just one function? Well, I got to get a common denominator. Then I can take the square root of each side. So secant of x equals plus or minus, what's the square root of 1 plus the square root, 1 plus cotangent square root of x? Well, you can't do anything to that. So it's just a square root. But the square root of cotangent squared, just cotangent of x. That's where it ends up. Okay, so you'll have 4 problems like that, where you're simplifying into something like that. Okay, then you'll have 4 problems where I give you one trig function, you have to find the other 5. So let's say the sine of x equals 3/8 in quadrant number 2. So I know the sine of x. I want to find then the cosine of x, the tangent of x, the cosecant of x, the secant of x, and the cotangent of x. Out of these 5 trig functions, if I'm given the sine of x, what would be the easiest to find? What would be the easiest to find? Not the cosine. That uses a Pythagorean. That's the second easiest to find. We'll go there second. What's even easier? What's the reciprocal function of sine? Cosecant. What's the cosecant going to be?
8/3.
8/3. It's a reciprocal. Boom. Okay? So, find the easiest one first. Now, we're going to use a Pythagorean identity to find cosine. We know that sine squared of x plus cosine squared of x equals 1, right? We already know sine squared is 3/8. So 3/8 squared plus cosine squared of x equals 1. What's 3/8 squared? 9 over 64. If we subtract 9/64 from each side, 1 is 64/64. 64/64 minus 9/64 is 55/64, correct? And then what do we do to each side?
Square root.
Square root. You are good. So the cosine of x equals either positive or negative. Now, this is important. Quadrant 1, cosine is positive, sine is positive, tangent is positive. Quadrant 2, cosine is... No, you can't put this on your note card. You got to be smart. Cosine deals with the x, right? So if we're going this way on the x-axis, we are negative. So cosine is negative, sine is positive because we're going up, and sine over cosine would be negative. Third quadrant, cosine is negative. We're going to the left. The x's are negative. The sine is negative. The tangent, negative divided by negative, is a positive. Quadrant 4, cosine, because we're going to the right, is positive. Sine, because we're going down, is negative. Tangent, positive, or a negative divided by positive, is a negative. Okay, so since we're in quadrant 2, cosine is going to be negative square root of 55 over, what's square root of 64? 8. Okay, negative square root of 55. Whoa. Negative square root of 55 over 8. Okay? Now, once I have cosine, what's super easy to find out a cosine? Secant. So the secant of x is negative 8 over the square root of 55. Can we leave square root of 55 on the bottom? No. So multiply top and bottom by square root of 55. So the secant is negative 8 square root of 55 over 55. Now we just have tangent and cotangent left. What is tangent equal to? What over what? 1 over cotangent, but that doesn't get me anywhere when cotangent is blank. Sine over cosine. So we can do sine over cosine. Or, I could find cotangent because cosecant's here. Remember, we have Pythagorean identity, which says cosecant squared of x equals cotangent squared of x plus 1. So I could go 8/3 squared equals cotangent squared of x plus 1. We do this is 64/9 equals cotangent squared of x plus 1. If we subtract 1 from each side, because I want to get cotangent squared alone, 1 is 9/9. So what's 64 minus 1? 9. 55/9, take square root of each side. We get square root of 55 over 3. And it's going to be negative because we're in second quadrant. If we flip that upside down, we get 3 over square root of 55. Can't leave it like that, so it's 3 square root of 55 over 55. There we go. Ooh, that was a lot, Mr. Bierschbach. Maybe it was. I'll let you write. Then I'll clue you in on something. Now, up here, what do we say secant was equal to? It was 1 plus cotangent squared over cotangent. So if cotangent would be like a nice number, we could use this to figure out this. Or if tangent was a nice number, we could use this to figure out this. Okay? So you can use your homework problems from 17 through 22 to kind of make shortcuts. If you have like a nice number, like a 2 in here, you can just slap them in and figure it out. Okay? Into the problems from 17 through 22. But if they're not nice numbers, if they involve square roots, probably use Pythagorean identities. Okay, let's do one more, because 2a gets out at 28. Let's do one more, and then I'll let you get started on this. Let's say let's do this. Let's say the secant of x equals 2 in quadrant number 4. The secant of x equals 2 in quadrant 4. What's everything else? So I want the sine of x, the cosine of x, the tangent of x, the cosecant of x, and the cotangent of x. All right. What's easiest to find? Cosine. What's cosine? 1/2, right? It's just the reciprocal of 2. Okay? Now, secant and what are in a Pythagorean identity together? Secant and tangent. So I know secant squared of x equals tangent squared of x plus 1. So 2 squared equals tangent squared of x plus 1. So this is 4 equals tangent squared of x plus 1. Subtract 1. 3 equals tangent squared of x. So if we take the square root of each side, tangent of x equals square root of 3. Is it going to be positive or negative with us being in quadrant 4? Negative. Okay. What's the reciprocal function of tangent? Cotangent. So cotangent of x equals 1 over square root of 3, and it's negative. Can't leave square root of 3 on the bottom. So multiply top and bottom by square root of 3. So it's negative square root of 3 over 3 for cotangent. Now we just have sine and cosecant, so let's do sine.
Excuse the interruption, students. There is a survey going out right now. Please check your emails and fill that out.
So we replace cosine squared with 1/2, because that's what it was over here. What's 1/2 squared? 1/4. Thank you. If we subtract 1/4 from each side, sine squared of x equals 3/4. If we take the square root of each side, sine of x is the square root of 3 over 2. When we're in quadrant 4, we are negative. And finally, cosecant. Flip over that. Can't leave square root of 3 on the bottom, so we multiply top and bottom by square root of 3. So it's negative 2 square root of 3 over 3. Bada bing, bada boom, we're done. So, 8 problems to do. If you get them done in class today, you're a rock star. Page 165, we're doing 19 through 26, all of them. Okay, you might have some out of class work to do for once.